All right, so here's the solution video for the second day of 3.1, average value, and part one of the fundamental theorem. Remember, average value is just a formula where we put 1 over b minus a and then multiply it by our integral. So essentially, it's what we were doing the first day of 3.1 with an added step of dividing by b minus a. So number 16, they want the average value from 3 to 7 of x minus 3 quantities squared. I decided to use u substitution. You could multiply this one out and just use the anti-power rule, but you'll notice again I've got my 1 over b minus a. So I find my derivative of u, I rewrite my integral, find my antiderivative. Once I've got that antiderivative, I just go ahead and follow through on my fundamental theorem. Again, notice my 1 over b minus a. Multiply that by the 1/3 for my anti-power rule to get 1/12. And then it's just a matter, again, f of b minus f of a. Feel free to use a calculator when you're finishing these up. If you don't want to be doing them by hand, that's fine. So you're welcome to give the decimal equivalent to 16/3. All right, 17, again, average value from 0 to 3 of square root of x. So I've got 1 over b minus a. I've got my integral from a to b of the function. So I find my antiderivative for x to the 1/2. So add 1 to the exponent, multiply by the reciprocal. Again, all I'm going to do is take this b minus a, 1 over b minus a, pardon me, and multiply. So I get 2/9. And then it's just a matter of f of b minus f of a. And again, feel free to use your calculator. Now, part one of the fundamental theorem is really just a trick you should recognize right away because we have a variable for a or for b. As soon as you see a variable for a or for b, you know you're dealing with part one. In this case, since the variable's in the b location, I'm going to use the positive function, and I simply substitute in for wherever I see the t, and I take the derivative of what I substituted in, and then simplify. Same thing in 26. As soon as I see a variable for a or b, I know that I'm just substituting it in wherever I see the t value, so that's what I've done, and then I take the derivative of what I substituted in. Again, it's important to take the derivative of what you substituted in. 27, this time the variable is in the a location, so I need to put a negative in front of my function. That comes from the fact that we would have had f of b minus f of a. Okay, so the minus here is why I have the minus cosine. I substitute in x for t, take the derivative of what I substituted in. Again, it's the derivative of what I substituted in, and I get my function. So again, I see a variable for a or for b. This time it's b, so I'm going to use the positive function. I substitute in x squared wherever I see t, so that gets me x squared squared. And then again, I take the derivative of what I substituted in. I substituted in x squared, so I take its derivative. And then I have just a little bit of simplifying to do. 32, again, I substitute in whatever I see, wherever I see a t value, so I end up with e to the 5 root x, and then I know my derivative for square root of x is 1 over 2 root x. Again, you're taking the derivative of what you substituted in. So 33, again, I substitute in the variable wherever I see t values, so that's going to get me x squared natural log of x squared, and then I take the derivative of what I substituted in. Oh, made a mistake in 36. And so then finally, since I see that my variable's in the a location, I should have a negative in front of all this. And so I substitute in wherever I see a t value. I take the derivative of what I substituted in. And then if you want to distribute or not distribute, that's up to you. All right, hopefully this helps. If not, feel free to ask questions in class.